Bismillah. So today we start chapter 5, the relational data model and relational database constraints. So this is the outline of this chapter. So what is a relation? The relational model of data is based on the concept of a relation. A relation is a mathematical concept based on set theory. You have studied set theory before in your discrete math course. So the relation is a concept based on set theory. The relational model was first proposed by a researcher named Dr. E.F. Codd of IBM. In 1970, he published a research paper called A Relational Model for Large Shared Data Banks. It was published in the ACM Journal in 1970. And since the publication of this paper, it caused a major revolution in the field of database management. And the relational data model became very popular very quickly. And most of the databases in the industry started using the relational data model. And for his contribution, Dr. Codd received the ACM Turing Award. The ACM Turing Award, is, some of you may know, is the highest award in computer science. It's called the Nobel Prize of Computer Science, the ACM Turing Award. Okay, so some definitions. A relation is what we call a table. So relation is basically a table of values, and a relation contains a set of rows and also there is a set of columns. Now each row represents a particular real world entity or relationship, and in the relational model a row is called tuple. Rows are called tuples in the formal model. And we have columns also. Each column has a column header which tells us the meaning of the column. So in the relational model, the column is called attribute and the column header is called attribute name. So each column is called an attribute. So this figure illustrates a relation. You have seen this figure before. So the name of the relation is student. Usually the relation name is in bold all caps. And these are the columns in the relation student. And each column has a header. So the columns are the attributes of the relation. Each column is an attribute of the relation. And each column will have a header. So the first column header is name. The second column header is SSN. Then home phone number and so on. And there are a number of rows in the table. Each row in the relation is called a tuple. A row is called a tuple in the relational model. So these are the tuples. There are 5 tuples in this student relation. So that's basically what a relation is. A relation is simply what we know as a table. And a relation consists of tuples and attributes. Each attribute has a particular attribute header or name. Some formal definitions. Schema, we already know what a schema is. Schema is the structure of the table. So in the formal definition of schema of a relation is denoted like this. We have R and then in parentheses A1, A2, an. R is the name of the relation. So R is the name of the relation, the name of the table. And A1, A2, etc. These are the attributes of the relation and the attributes of the relation. So let's take an example. We have the relational schema for the customer relation. And so this is the name of the customer relation. And in parentheses, we have the attributes of the customer relation. So there are 4 attributes in the customer relation: customer ID, customer name, address, phone number. So this is the schema for the customer relation. Each attribute has a domain. Domain is basically the set of valid values that the attribute can take. So the domain of customer ID, let's say, is a 6-digit number. So any 6-digit number is a value that can be taken by customer ID. customer name, for example, the domain could be varchar20. Domain you can also think of as the data type of the attribute. So if the customer name domain is varchar20, then customer name can take any string of up to 20 characters. Let's take a look at the formal definition of a tuple. A tuple is defined as an ordered set of values. A tuple is an ordered set of values, and it is enclosed in angle brackets like this. So for example, the customer relation that we just looked at, a tuple in a customer relation can look something like this. So we have angle brackets, and then we have a value here. There are 1, 2, 3, 4 values. What do these values represent? Let's go back to the schema. In the schema, we have customer ID, then name, then address, phone number. So the first value is the value for the customer ID, followed by the name, followed by address, and then the phone number. So inside the customer relation, we can have a tuple like this with these values for each of the attributes. So the value of each attribute must be from the domain. So the value of customer ID must be a 6-digit number. You cannot put ABCD here. It must be a 6-digit number, and so on. So each attribute value must come from the domain of that particular attribute. And relation is defined as a set of such tuples. A table is a set of rows. A relation is a set of tuples. Another term we have seen before, relation state. If you remember, the relation state is the content of the table at a particular time. The data content of the table at a particular time, that is the relation state. This is the formal definition of relation state. The relation state is a subset of the Cartesian product of the domains of its attributes. Now what does this mean? Let's take an example to illustrate this definition. So let's say we have a relation R with two attributes A1, A2. So this is the schema given. And the domain of A1, meaning all the values that A1 can take, let's say is simply 0 and 1. Meaning the attribute A1 can take only two values, either 0 or 1. And the domain of A2 is a set of three elements A, B, C, meaning A2 can take only values A or B or C. Okay. Now, if I take the Cartesian product represented by X of these two sets, because the domains of an attribute is basically a set of values. If I take the Cartesian product of these two sets, then what do I get? All possible combinations, as you know, of the Cartesian product. So what are all possible combinations in this case? You can have 0A, 0B, 0C, 1A, 1B, 1C. So these are the six possible values if I take the Cartesian product. Notice that each element in this set is basically a tuple value. So notice that we're using the angle bracket. So 0A, this is a tuple value. 0B, this is another tuple value, 0C, and so on. So there are six possible tuple values, and we have a set of six elements. Now, if you think about this set, any tuple value that can be inserted in the relation R must come from this set. For example, let's say currently, so the small r represents relation state and capital R is the name of the relation, capital R. So let's say currently in the relation there are three tuples, 0A, 0B, 1C. Now notice that these three elements are already in this set. So we can say that the relation state is a subset of this set. In fact, any possible tuple value that can be inserted in the relation R must come from this set. Is there any other tuple value that can be inserted in the relation other than these six? tuple values? The answer is no, right? Because we have taken the domains of the attributes. We have taken the Cartesian products of all possible combinations. Therefore, any tuple value that can be inserted in the relation R must come from this set. So therefore, we can say that the relation state small r of the relation capital R, the relation state, is a subset of this set. And what is this set? This set is simply the Cartesian product of the domains of A1 and A2. Correct? So now if we generalize, we get this definition. The relation state is a subset of the Cartesian product of the domains of its attributes. And of course, each domain contains the set of all possible values the attribute can take. So the domain of customer name, let's say, is bar chart 25, meaning it can take any string of up to 25 characters. Summary of the formal definitions. This is the relation schema. Capital R is the name of the relation, and in parentheses we have the attributes of the relation. The small r represents state. So state of the relation capital R is a subset of the Cartesian product of the domains of its attributes, as we just saw in the definition. Right? The state of the relation is simply a set of tuples, and each tuple is an ordered set of values. So V1 is the value for attribute A1, V2 is the value for attribute A2, and so on. Vn is the attribute value for attribute An. So inside the tuple, the values must be ordered, and the order is determined by the schema. In which order were the attributes in the schema, the values must follow that same order. So mapping between informal terms and the formal terms used in a relational model. Informally, what we call a table is formally known as a relation. A column header is called an attribute of the relation. All possible column values is the domain of the attribute. A row in the table is formally called the tuple in a relation. Table definition is the schema of the relation schema. And populated table, meaning the data content of the table at a particular time, that is the state of the relation. Now here we have an example of a state of the relation student. We have these 5 tuples here. Now what if I were to change the order of the tuples? So for example, here Benjamin Bear is the first tuple, then we have Chung and so on. If I put, let's say, Benjamin Bear last, Chung second last, and so on, so I flip the order of the tuples, but the values are the same. No values have changed. I have simply switched the order of the tuples in a different order. Does it make a difference in the relation states? The answer is no, it doesn't. Because why? We define a relation state, if you remember. A relation state is a set of tuples. A relation state is a set of tuples. And in a set, does the order of the elements matter? The answer is no. T1, T2, Tn is the same as Tn, T2, T1. The order does not matter. So if I change the order of the tuples, so here we have Benjamin first and Chung second and so on. If I change the order, put Benjamin last, Chung second last, it does not affect the relation state. It is the same state. So this figure and this figure, they show the identical state of the relation student. The relation state has not changed at all. However, within a particular tuple, the order of the values, is it important? The answer is yes. Within a particular tuple, the order of the values is very important. It must follow the schema. So the first value of the tuple must be the student name, followed by SSN, then home phone number, address, office phone, age, GPA. And every tuple must follow this particular order of values. As you see that every tuple must have this particular order of values. So as we said, the tuples are not considered to be ordered. So even though the tuple orders are changed, the relation state remains the same. But within a particular tuple, we will consider the attribute values to be ordered. Within a particular tuple, the attribute values are ordered. In a relation, all attribute values must be atomic, single atomic values. In the ER model for entities, the entity attributes could be simple, could be composite, could be multivalued in the ER model. However, in the relational model, the attribute of a relation must only be simple, meaning the value of the attribute in a relational model can only take one single atomic value. And that value, of course, must come from the domain of the attribute. The only exception is a value of an attribute could be null. Null basically means the value of the attribute is unknown or inapplicable or not available. That is the only exception. Otherwise, the attribute must take a value that comes from the domain of the attribute.